Okay, hello everyone. Welcome to the first class after the break that we had. Hopefully, you guys had a little bit of time to chill and also maybe do the homework. So yeah, it's been a couple of weeks since we last had our class, and I must tell you, I really rested. I traveled to Austria, and it was really cool. And now I'm back, and I'm not the happiest about being back. It was really fun not to work for a while, honestly. I'm just joking. I was really looking forward to this class, actually, because I just want to see what you guys have been up to. Have you been able to finish the homework? So let me just open up the right project here. Today we have kind of a free lesson, I think. Let's see. Uh, it should be here, but whatever. Module 1, that's where we're at. The last lesson was lesson number 17, collections part 2. So today's lesson is going to be elective. Let me send it here. And we're going to go through the presentation real quick. Then we're first going to probably check out the homework, then go through the presentation. It's a quick one. And we only have a couple lessons to go, well, 7, 8 maybe. So we're going to be done with module 1 soon enough. Okay. So first things first, let's do a quick recap of what we have done last time before the break. I'll do a more thorough recap of both lessons 16 and 17. We basically talked about some different data structures that we can use, collections as they're called in Java, and we explained what a set is. We also explained what hash from a hash set means. Hashing is a more general process. We remember that it's a process of taking an input, producing some hash value. Hash value usually is an integer. I mean, generally, hashing is a process of taking one thing and producing some output that's going to be recognizable for that thing. But here in Java, the implementation is such that you need to provide an integer when you're hashing something. And based on that, it's actually quite a lot easier later to retrieve elements to see whether they're there and so on. So cache collections will have the advantage of being super fast just due to the process of hashing. And the set as a collection is just one that, well, does set operations like adding, removing, seeing whether something is in there or not. The set is unordered by default, and that's pretty much it. It can contain elements. You can add, remove. You can go through all of them. You can't really like enumerate them. There is no fifth element in a set. There is no first element in a set. In an unsorted set, there are sorted sets as well. So sets are very useful when we need to check whether something is in there when we have a bunch of elements. We remember that to check whether something is in an array, we need to go through all the elements at least once. We need to visit each element and say, are you the thing I'm looking for? No. Okay, moving on. And to see whether something is in a set, you just need to remember that story about the library, Harry Potter book, and so on. So the librarian just asks what you want. You say Harry Potter by J.K. Rowling, and she literally turns, and we can imagine she's like moving really fast. She's in the room with the JK, and there's the H section where the book stands or not, you know. So you can imagine when you are checking whether something is contained in a set, it's almost instant and almost doesn't depend on the size of the set. That's what sets are quite useful for. Second class, we have learned a map. A map is basically a more generalized array. In an array, you are accessing elements via their indexes, right? In element number 7, element number 3, here you're accessing elements using something of your own choosing. So basically, we have a key and we have a value, and we're going to map this key onto some value. You can map anything onto anything. In arrays, we always map a number onto some value, be it a string or a person or whatever. Here we are more we have more freedom. We can map anything onto anything. That's why maps sometimes are called dictionaries, or in some languages they're also called associative arrays. They all refer to the same thing: the map, the dictionary, the associative array. They all talk about the same data structure, a way to basically access an element via some key, and that key might be anything. So for the associative arrays, for example, in Python, you can do there's in Python they're called dicts, and you literally do something like this: dict equals, and then you do a new dict like this, And then you can do something like dict of whatever equals 4, So you can even use this array-like syntax in Python. Uh, and in JavaScript as well, you can use this array-like syntax. And that's why they're called associative arrays, because we associate this value with some other value. And of course, this must be unique. I cannot have two keys that are the same. And in Java, all of the logic is the same, just the syntax is slightly different. We use something called a map. We declare what type we're going to use for the key and for the value, and then we put stuff in the map. We put stuff in the map, we take stuff from the map, we update values sometimes, and so on. We can check whether we can get all the keys, we can get all the values, and so on. Everything that you can imagine. I mean, it exists from the methods. And that was the point of the second class. And we also introduced the sorted collections. By the way, if you were wondering, is there a tree set? Yes, of course. If you want your set sorted, you can have it be sorted, tree set. Pretty much a different set. It's not a hash set, it's a tree set. And it's actually implementing an interface called sorted set. So that's more, let's say, strict, right? A set itself. I mean, a sorted set is a set, really. It extends the set, adding some extra stuff, right? Remember that. It's a sorted set, so of course it's a set itself, but with some extra thingies like being sorted, So we have a map and a set, and they can be, well, sorted, in which case you use a tree set or a tree map, or they can be unsorted, in which case you use a hash set or a hash map. That's basically it. We've covered all of these, are going to be really important, and we have seen here in these couple of examples how, maps can be quite useful for a variety of things. Right, here we counted all the letters. We could have counted all the words, and that's going to be probably your homework for next class, to write a program that's going to count all the words. Let me show you what I mean, like word counter something, not Grammarly, but like wordcounter.net. And you just type something, hello, this is my piece of text, and this, hello, and this is your homework. Like, it's super simple. I give you a sentence or a bunch of sentences, a piece of text generally, and I want you to produce something like this. Hello was there 2 times, peace was there 1 time, text was there 1 time, and so on. So basically, let's see, is it ignoring this? Yes, it is. Why is it? Keyword, not keyword, but like, is there words? How the hell do I see the counter here? It's trying to be smart. Let's see another one, word counter IO. But you see the point. This, hello, there. Let's see. Let me move the chat. Why is it not counting this? God damn it. Okay, this is super weird. I don't know. Like, I used this one previously, but I'm not sure, like, why is it not showing the word this and is and off. Why are these keywords? I don't want keywords. I can't be bothered with this. Your task is still going to be to make something similar to this. I give you a sentence, basically, and you give me top words sorted by how many times they're appearing. And I'm going to write it down here for example, in this file. So additional homework, if you want to try to do it, create a word counter that's given a string, and it displays the top words sorted by the number of occurrences, something like that. I'm not going to say anything else. I want you to see what structures you're going to use and so on. And then we're going to see if your programs actually work by testing them thoroughly. So test your programs thoroughly. That's what I would suggest. There are many things that you can get wrong here. I'm not sure why this bloody thing is not working. Why keyword, it's probably assuming that I don't want to count is for some reason or something, one thing or the other. I have no idea, actually. So, okay, I think this is a single word. but like it's certainly recognizing that there's 12 words in this. Okay, that's going to be your additional homework. With that out of the way, let's see the harder thing that you've been asked to do during the break. This should be quite easy, but I just want to see if you are able to do it properly, and I'm going to test it really thoroughly, so make sure that it works with all kinds of inputs. That's all I'm going to say. So let me now see what you guys have submitted. What's Slackbot all about? Okay, thank you for nothing, Slackbot. Let me see what we have here. I saw that somebody posted here, so let's see that. Oleg. So let me copy this whole thing. It's going to be easier to look at. You pasted both things here, I'm assuming. I'm just going to take the whole thing and I'm going to go, where's my homework package? Let's just create something here. I need a new package because it's also called main. New package real quickly, and now let's do main, and just a quick thing here, let's put the package name. We're going to need to include a bunch of stuff, and prediction words, map, we're going to need the map, we need the hash map. Alt enter is the shortcut if you're wondering. A list also, alt enter, then hit enter a couple of times. And here, public class service should be declared. Deep copy map. Okay, so this would need to be a separate file. So let's quickly do that also. And Java class service. Then just gonna paste that there real quick. And it's also probably we need a linked list to import the linked list. Okay, and prediction words should also be on separate. Yeah, mode class. That would have been cool. Okay, so let's see what Oleg had submitted. Is he here today with us? Not that I can see. Unfortunately, I can't ask any questions of him, but I'll give a review, so hopefully he'll watch the video and let me know in questions in chat whether something was unclear or whatever. Okay, so first thing that I see is I like the fact that it's separated into several files. That's supposed to be like that. We're supposed to actually make some classes, and this one is supposed to do everything regarding prediction. There should be a runner file. We can call it main, we can call it anything, doesn't really matter. But that file is supposed to do all the talking to the user, and it's supposed to just pass stuff to the prediction. So it's like we have a runner, and the runner is going to take input from the user, print messages to the user, and so on and so on. And it's going to send all the actual work to prediction. I mean, whatever you want to call that class, predictor, word predictor, suggester, whatever. And that's the part of design. Service, I'm assuming, is just like a util class. We usually call these utils. As you can see here, the word util, literally like a utility, something that you often use. And util classes usually have a bunch of static methods like, I don't know, capitalizing the first letter, or validating an email, or just some stuff that you use throughout your code in a million places. You need to validate your email probably in a lot of places, or to trim your string to get rid of all the extra white spaces at the beginning and at the end, or just things like that, you know. So we usually have a separate class for that called util, and then in utils you can put a lot of stuff. If your util grows too large, you can separate it into, I don't know, formatting util and some other util, calculation util, or whatever. But usually we will want to have these methods that can be used, like deep copying a map, for example, a util method. We want to have this in a separate file. So really great work on that as well. Now, the main focus is going to be on this actual prediction words class, but let me just see what I can see here. I love the fact that you're noticing the need to use variables for all of these things, because then at some point it might be easier to translate this. Maybe we want to support multi-language, multilinguality, multi-something, I don't know the word, but maybe we want to support multiple languages at some point. And having these be variables is a precursor to that, you know. Even better, of course, now I'm just talking out of my ass. That is, I mean, really well done, but I'm talking about always about the next level. Next level for this would be not even to have a single message here, You have a thing called text displayer or user information or whatever. I'm inventing names now, but literally to have a separate class, even with a job to print all the messages and to get all the inputs from the user. So now our runner might look something like user information or get information from the user and so on, and user information or dot show information to the user. And then we're literally separating things into logical parts. User information, or the funny name that I chose here, will be easily replaceable, right? We want to switch from running in the terminal to running, well, with a GUI, with a graphical user interface. Easy. We just change how this thing is working. We don't have to change anything here in code, right? Now we kind of do. This thing is depending on the scanner. It's literally talking to the scanner directly. Again, I'm just pointing out we are learning, and this is your first project. So of course, even if you have everything in the main file, it's expected, right? We haven't really done much of system design, and we will a little bit, as I think that's a quite important topic. I mean, yes, it's a beginner course, but I try to cram in as much info as I can. So basically, the best version of this would be to have your runner, your main, just be calling a bunch of stuff. Call the guy responsible for fetching you user input and for displaying, messages to the user. That thing can be called console printer or GUI something. Next, what do you need to do? Well, you need to also predict some words. Well, call the guy who's predicting the words. We already have that. So basically, the runner itself is not supposed to even know about scanners. It's not supposed to know about maps, and it doesn't, which is great. You could have everything in a single file, and it would still be proper code, but not the best by design standards. So let's see. Now we're reading some lines and we're seeing if the user wants to stop or not, and so on. So this is all going to be really nicely worked. Let's test it, and then I'm going to go to the main piece of feedback, which is going to be this class. Enter the number of suggested words. Enter the number, let's say 3. Enter text. This is going to be great. This is awesome. This was cool. This should. This will. This will. You can already assume, okay. So it's just, based on this text, but what word does it use for the prediction? Show predicted word. Okay, so I have a little flaw in the design here. I saw in the screenshot that you sent that you actually took this piece of text, but how the hell do you know which word to get to? The last word that it sees for will. Okay. Okay, so okay, now we're talking about the user experience. Not loving the user experience. I need to enter the text and then separately enter the word that I'm looking for. So let me just real quickly copy this, so I'm not going to type it again, and rerun. I can keep entering the text. Oh yeah, I could have done that, but I want you to ask me for the word separately, right? And I'm just going to add the word this to the end because I want the predictions for the word this. And this is what we wanted to see, like will, is, and was, because we have is, and then we have is twice, we have was once, we have should once, and we have will and will twice. So it's actually going to do will and is because that one appears twice, and then we have the was here. If we have 3 suggestions, what is it supposed to do now? Nothing really. Enter. Okay, so it's like not really doing a lot after that. We need what if I type quit or Q? Nothing. If line equals stop program, if it equals this exactly, yeah, it's not gonna happen anymore because you closed the scanner or you're closing it afterwards. I just need to enter another piece of text. No, I don't know how to exit this, but still, that's not super important. What's important is now let's talk about the design. You have some really good ideas here. You are setting some number of words. you are having some variable. But one a big thing here is that all of these things are static. And let me explain why they're not supposed to be. Now I cannot have two word predictions running at the same time. It's simply always it's a single thing. When you make everything in a class static, you can only have a single instance running. You might wonder why is that a huge deal? Well, imagine only being able to create one person. You know, kind of weird, right? Only being able to play one game. Why not have two windows running the same game at the same time, right? Why not have two word predictors? One for me and one for you, or one for Serbian, one for English, or whatever. Making everything static is akin to not even having a class. I could literally cut all of this. I could cut all of this out of here and paste it here, and everything would work just the same. So it's akin to even not having a class, you know. And by the way, I just need to get rid of prediction words now everywhere. If you're wondering why this doesn't work, look at this. I literally took this, copy pasted the code here in the same. It will work the same, trust me. So why is this an issue? Well, again, what if I'm switching my keyboard from, which is literally what I'm doing. I have a Serbian keyboard and I have English keyboard in my phone, right? And it's running two different word suggesters for each one of my keyboards, if that makes sense, you know. So we want to actually be able to make, let me just get rid of this and I'll undo this. So we want to be able to make instances of this class, right? I want to have one word suggester that suggests 3 words and another one that suggests 5 from these words, and one that suggests 4 from these words, and so on. So actually making everything here non-static. And then instead of using the static stuff as you are here and there, like instead of doing this, you do prediction words equals new prediction words. You create a new one, and then we can have multiple. I can have prediction words 2, prediction words 3, and every method is supposed to be non-static. Every variable here is supposed to be non-static, and now every one of these prediction words that we have created will have its own copy. And I love the fact that you noticed that number of words is something that we kind of need to remember. We don't need to like ask the user every time, how many words do you want? How many words do you want? It might be a good thing to remember, and then it might be prone to change. That's why you have a setter. Really well done. Everything here is super well done. I would just remove the word static a million times, and that's it. So literally replace all static with non-static. And here you would just replace this with this, and we got ourselves a much, much better program. Now, of course, instead of calling this like this, we call it on some actual prediction words. So let me replace this with prediction word with the lowercase p, and I'm going to replace, and there we go. Everything now works, but it's much better designed. Oops, didn't mean to delete the last one. So we create a instance of this, we feed it words, put words to storage, and then we can keep adding the words to this one. And then I switch the keyboard, we start working with another one. I switch back, we keep working with this one, and so on. So let me know, everybody else, are you seeing the point here? Should I repeat some more, or let me know if you understand what I'm saying here. And this is, by the way, the most common thing beginners do ever. Like you guys always make everything static, and that's fine because it's more natural. I don't know. I can't remember when I was starting out whether I made everything static. I probably did. But the thing is, I'm not saying this code is wrong. It was obviously right and it worked, right? It's all cool. But the thing is, this is just slightly a better design. We don't want to make everything static in a class. If we do, then making that into a class, I mean, that's a util class, isn't it? So I'm going to, of course, undo all of my changes here. And I'm going to undo this as well. Just to put it back to the way it was. But you now notice, hopefully you understand why this should all be non-static. And one final like little flaw from the design perspective, show predicted words of the word to, you know, I want this. This is just the design flaw. I mean, I want to give you the word that I'm looking for. This put storage does a lot. It's just the last word in previous line. It's doing a lot. This is not its job. Uh, it simply isn't. Put words to storage. You just put all the words to storage. That's all you do, which is great. I'm assuming you're doing it correctly here. We're gonna check this method in a second. So that's awesome. But also, it's not your job to remember the last word. It's somebody else's job to tell you what word they want the prediction for. You know. So here, the design should have been string word, and that's it. That's the whole story. And then I can pass here the word that the user enters, like to or whatever. This would have been slightly better design. Of course, we don't use the last word at all. The last word literally doesn't need to exist, and that's it. That's everything that I would change here. So now that I said everything that I would change, let me see everything here how it's working. So the biggest thing that I care about is word storage is a map of string and then a map of string integer. Why is this? Well, because I wrote it in the document. But why? Why do we need this? Well, we look at the document. We're actually, you should be able to come up with this on your own. That's all I'm saying. I was actually thinking whether to leave it in there or not. And if I remove it, I'm assuming most of people are not going to be able to do the homework. But I said as well, just read the functional specification if you want a really hard challenge, right? If you read the whole thing, it's going to be slightly easier, which is again cool. But I'm just saying your clients are not going to tell you, hey, I want you to use a map of string and the map of string integer. Nobody's going to tell you that. You have to decide that on your own. And that's going to be the hardest part, right? Where's the homework? Here it is. So imagine just working off of these few sentences. Of course, here I'm explaining a little bit because we want everybody to be able to do it and so on. So hopefully you understand why we're using a map of string and a map of string integer. We could have, in principle, used a map and a list of string here. Would this work? Yes, of course. We're mapping a single word onto all of the words coming after it. A list, right? But now when the time comes for us to produce results, we have to count how many times. So out of this list, we have to do that sub-task of creating a map. So why not maintain a map the whole way, right? So I'm saying here, there are possibly different solutions. I'm not saying this one is the best or even optimal for that matter. I'm assuming Google doesn't do this because it would be a bunch of data after a while, for each word, remember every word that ever appeared. Of course, they're not doing that, but yeah, we're simplifying. That's why we're doing a simpler thing, right? But at least here would have worked. It would have worked. It would require a little bit less work when adding the word and a little bit more work when retrieving the word. But it would also be a little bit slower because we would have to go through this list every time. So for the same word like to, if we wanted to fetch predictions 10 times, we would have to do 10 times the creation of the map from this list and so on. So again, why are we using this? Because I said so. Is it the best? No. Is it good? Yeah, kinda, for some circumstances. If you have a billion words, probably not that good. For each one of those words, you're going to have this whole map and so on and so on. It's going to grow rapidly, But who cares? This was just for demonstration purposes. So why do we use a map of a map? Well, because we want to map a word onto something like this, which looks like a map again. That's why we're using a map of a string and another map of a string and an integer. I even opened Paint to draw all of this stuff for you guys. So hopefully you understand why we're using a map of a map. Once we understand that, so this is going to be contained in our storage. What do we need to do? We need to keep track of pretty much every word. So the current word and then the word that comes after it. So we're here going to put, of course, the well-known if. Let me see. If the storage doesn't contain the key, put this inside of there and put words to storage. And here again, if the word is coming there for the first time, we're going to put it there to be once. And if the word has been already there, we're going to put the previous value plus one. Really well done. Not much to say here. I love the fact that this is a separate method because it's used in two places. So that could have been extracted. Really nicely done. Show predicted words. That's going to do pretty much predict next words. Let's see that guy. Uh, okay, this guy is doing the calculations. This guy is fetching the key of all the words, and then it's taking a map. It's taking a copy for some reason. I'm not sure why, but maybe it's needed. And then it's trying to figure out the most often word and removing it until we have enough number of words, which is, again, something that I really like, that this is a parameter. This should be a parameter. And some people have been designing it by having a method called predict next word, string word, and int number. This is fine. I'm okay with this piece of design, right? Like number of suggestions or something. Hopefully you guys understand this is a viable design as well, but it's slightly worse, I would say, because like this thing could be remembered. Like most of the time, you are predicting the same number of words. For example, in my Google report, all of the time it's three, right? So yeah, you could also save that three. You don't have to ask me every time. So usually these things that are not that often changed, like of course this word is going to change all the time, so it makes no sense to remember it. Like with this last word, it kind of doesn't make sense to remember it, right? But this thing, this number of words, is going to be kind of constant for most of the lifetime. So it's really a great idea to extract it into a field, into a variable that belongs to the class. Of course, not static, but still, it's a great idea to do that. And again, I'm fine with both designs. Not having this here, also fine. Okay, getting the words, going through all the words in a map, pretty much. I'm not sure why you needed the copy of the map, but that doesn't matter all that much. And we're fetching the words one by one, removing them. Because you're removing from the copy. You don't want to touch the original. I understand. So, okay, cool. That's fine. Basically, he's creating a copy here because he doesn't want to touch the original list, right? He doesn't want to, when he takes the word like, whoops, when he takes the word like do, he doesn't want to remove it from the original map. He removes it from the temporary map, like a copy, which is, again, cool by me. Okay, really well done by Olef. Thank you. And if you have any questions for me, do let me know in the chat whenever you're watching the video. Great work. Reading the tiny suggestion. Replace. Yeah, you have is empty. Okay, let's see the Glenn project, the one that we are all looking forward to. JDoodle. Let's see the JDoodle. Gboard. Gboard. Okay. Next word predictor. Gboard of 3. I like this. Run prompt. Okay, so I like the fact that you're even passing this in a constructor. Really cool. Gboard. I can tell you from. Can you think of the first thing I'm gonna say, Glenn, when I see this Gboard class doing everything? It's doing too much, and that's it. I mean, I love the fact that everything here. Okay, so you have a, yeah, of course you did. So what doesn't belong here in the Gboard? That's a question for all of you. What doesn't belong? Can you, in a couple of words, try to tell me what, from the first glance here, what doesn't belong here? We all understand, like Glenn wanted to keep it simple, and this is great. Gboard. The thing that I'm disliking here is it shouldn't have been GB run prompt. It should have been user relation guy run prompt. So Google, there should be a runner class. A runner class is going to connect every, like this one is the runner class. So it should connect all the other classes, like Gboard doing the Gboard stuff. I don't know, file reader doing the file reading stuff, uh, file writer doing the file writing stuff, user prompts doing the user prompt stuff, and so on. So Google Gboard is now currently doing two things. It's doing everything user related and everything Gboard related. Oh, yeah, of course. So the things that need to go from the Gboard class are everything related to scanner taking input, everything related to printing some stuff to the screen. So while user, blah, blah, blah. So this whole run prompt method pretty much doesn't belong. Welcome message, everything related to outputs doesn't belong. Every single system out print line doesn't belong. Right. Other than that, everything else belongs, right? So let's see it. Again, you nicely noticed the fact that we need non-static things here, and maybe the word limit shouldn't be final. That's just a little thing, right? Maybe it shouldn't be final. Maybe somebody decides, okay, I'm gonna go into settings. I no longer want 3 suggestions. I need 4. So maybe this thing is not supposed to be final. I'm okay with all the others being final because you can add stuff to the map, but you cannot change the map. Here you cannot do anything. So final means you are not ever to reassign this variable. This is kind of different than saying you cannot change the variable. You can change the variable, but you can change the content, not the reference. So here, contents and the reference is the same thing. It's a primitive data type. I cannot change this to 7 because that simply would be changing the reference. We would need that 7 put in somewhere else. So you cannot assign the value again. You can't use the equal. That's what final means. You cannot assign the value again. But here you can change the map. You can say map, put, map, remove, and so on. It's the same old map, just removing, adding stuff, and so on. So I will remove final here. Uh, Again, as I said, I like this that you are creating it with the word limit given at the start. Yeah, maybe you could also provide an empty constructor with the default word limit, and that's great. Now we are taking some input. I'm not going to go through that in detail. Raw user input, scanning, cleaning, really well done, of course. I mean, as always, you are thinking about the small details. I really appreciate that. You need to clean the input. You need to handle special cases, blah, blah, blah. Not here to discuss that. So now from the design perspective, a lot of printing the Gboard is doing. Gboard is supposed to be returning results. So print prediction would be actually get prediction. Again, it's not printing. It's not its job to print. It's its job to give me the result. And it's the caller's job to say print or put in a file or send to somebody or display in a UI and so on. So you usually never want to print. Printing is for babies, right? I'm joking a little bit, but printing is actually for us when doing console apps. We're not going to be doing a whole lot of printing in the production apps. We're going to be returning results, right? So I didn't want to be mean if that was mean. I'm sorry, but yeah, this is a much better method. Get word suggestions. This one I want to see be public because you give me a word and I give you a bunch of suggestions back. That's it. That's the design of a method. Int word prediction or the other one just goes into the printer or whatever, right? The Gboard just needs to take a word and give me a bunch of words back. And this is basically a perfect method, a perfect design of the method. So let's see the method now. We're taking the map and so on. And if the map doesn't exist, if there is no words, return an empty list. Really cool. Top keys add. Okay. So we're sorting and you're using something called a lambda here. The map. By the way, you could have kept a sorted map. That's another thing we could have done. We could have said sorted map here. So this map, no, but not really though. Could we? Because we sort only on the key. So we kind of have to flip the map anyway. So here we are basically taking a list of these entries and we're sorting them, entry list sort based on, well, B being the value here, being these integers. And then we're basically just getting either the word limit or however many words we have, which is again another great example of Glenn thinking about small detail, which I love. In fact, if you were testing this, you probably had a crash and you were like, what the hell is it crashing for? And it was crashing because you don't have enough elements, for example, but little things like this really matter because those make you a good programmer. You have to think about everything. What if there is not enough words for a word like two? Somebody entered only 2 words after it, so you don't have enough suggestions. Well, you need to take that into account. That's why Glenn is doing math.min of word limit and how many words we have. And this thing here that we're looking at, it's called a lambda function. We're going to learn them in module 2. Now, all that you need to know is that Glenn probably Googled this, which is, again, fine, of course, more than allowed. I mean, you're learning something new even by Googling. So what this will do is it's basically a little function created here in place. And that little function, you are using that little function to tell the sort how you want your stuff sorted. We can leave it at that. We don't have to explain anything more. Doesn't really matter. Like this little arrow denotes a lambda function, blah, blah, blah. It could have been also done without lambda function. I mean, we're going to learn them in our time in module 2 in like lesson something something. I don't know which one, but we are certainly going to spend a lot of time on lambda functions alone. So don't sweat about this too much. It's basically what it's doing is it's taking this thing and taking a list of these entries where each one of these pairs, like U7, Me4, Do21, each one of the pairs. So a single one line is one entry in a list. This is another entry in a list. This is another entry in a list. And what Glenn is doing is he's sorting them by this number. And that's what we can see. God damn, it's on the next tab. So what we can see here, A and B are the string and integer. Of course, lambdas, but it's all shortened, blah, blah, blah. But he's basically saying B compared to A. So use the comparison of integers to fetch the biggest, to determine who's bigger than whom when sorting. That's it. So yeah, other than that, I mean, of course, now we just add our top hits into the entry list using the for loop, and that's it. Adding the word, same story. If it doesn't exist, put the word in an inner map and then put that inner map in the outer map. What am I not? Okay. So put the inner map at the end in the outer map. Count if there was already the word in there, then take the previous count and put the count plus 1. That's it, basically. If the count didn't exist, by the way, Glenn, you could have used get or default here, really, for this. It would have been really cool, like get or default, and then you do word, comma 0, because get or default gives you the word, gives you the count that's there, or the default value if it's not. So you would have saved yourself these 4 lines. Could have been a single cool line called get or default. Of course, again, you are free to use those helper methods. I mean, they are there for us to use. So you're also free to use them as well. They might be they might be quite handy in certain circumstances. Other than that, I mean, I love it. It's really well done. From the design perspective, like all of your methods are really good. Add word, a helper method, going to be called in a bunch of places, private, awesome. Get word suggestions, this is the one I want to see public, right? I want this guy to be open to the public because that's the guy we want, right? Give me a word, I give you back a bunch of suggestions. Add word might even be public, maybe you want to add a single 2 words, like a pair, give me the first word, give me the second. And what else do I want to see public? I want to see the one where we're feeding it words. So that one is probably tied together with something here. Let me see what. Print word suggestions, not my scroll is not really working. Yeah, here, when the user is entering stuff, you're adding the words, cleaning the user input and so on. So I would love to see like a method called, I don't know, feed the suggester or add suggestion or add sentences, whatever. And you feed it a bunch of text and it actually parses the text as it's probably doing here, sentence event. Yeah, whatever. You understand my point. I want to be able to have a method to feed it more text. I want to be able to have a method to set how many suggestions do I want. And I want to be able, I'm not going to use that guy a whole lot, but whatever. I want to still be able to have control over that. And I want to be able to give you the word, you give me back the suggestions. Give me the word, give me back the suggestions. And that's it. So I'm pretty happy with what you have here. Let me know if you have any questions, and everybody else as well. If you have any questions about Glenn's work here or my feedback, let me know. Was it hard to do though? Was it challenging? Was it interesting? By the way, if you have any ideas of something that from the real world that you would love solved, we can talk about it, Yeah, I assume so as well. You can see you put in a lot of work. Really thank you for that, Glenn. And also thanks to, what was the name? Again, Oleg. Thank you, Oleg, for submitting. Oleg is watching from the shadows. I don't see him online a lot, but he really did a great job in solving the task as well. I I would love to hear your suggestions for anything, pretty much. Like these ideas just come to mind. I was really like seeing how people loved the end of the module project, and I was like, why can't we have one in the middle of the project? And I made one. And I was actually waiting for an inspiration. I mean, waiting for an idea to come by and for me to say, okay, this would be actually a great thing to make at this level of knowledge. We can make it, and we obviously did, right? So you guys, I mean, and it's a semi-complex program, right? It's something that you can even be proud of. And I'm always looking for ideas for such programs. For example, I actually created some minor programs for myself. I was trying to make a crossword. You all know what a crossword is. Crossword, crossword puzzle, this thing that you see in newspapers, right? I was trying to make this with my girlfriend, and I was like, oh, I'm going to make myself a little program that's going to help me. And of course, I still want to make it manually. By the way, coding a program that makes this for you is beyond my knowledge. I must tell you that because it's super hard. But coding a program which I tell, hey, I want letter T at the first position and letter M at the third position. And it gives me all the words that have 5 letters, T here, M here. I made that. I made myself I coded myself a little crossword maker helper, So things like these, like when you can code, you can do things like these for any purpose whatsoever, Like I was making a crossword. That's one of the examples, right? You can make an app that helps you with anything. Let me see what Glenn said. Create an application that helps on other side, very poorly worded. Yeah. So yeah, manage a cinema theater, sell tickets, check available seats, view sales statistics, more. Yeah, that would be a cool one as well. I mean, we can elaborate on that as well. If you guys want to try to do something like that, it would be cool. Like, or a library that manages books, or pretty much any other real world example that you can think of. You can even create an app that like gives people a chance to schedule hairdressers appointments or whatever, So we can make many different small apps, and if you are ever willing to do that, I mean, do it, and then I'm gonna review it as part of the curriculum. I mean, it's really useful. It's much more useful than what we will see from looking at my code. It's much better to see what you guys are doing and what mistakes you're making, because that actually is the best way to learn, I would say, by doing. Okay, I talked for a while. Let me know if you have any questions, and if you don't, we're gonna go for the break. And after the break, we're moving on with this lesson. And then I have some more interesting things to also put in there as well. If you don't have questions, I'll see you after the break.